Filter analysis is a completely new feature of Release 6. The name derives from the fact that you can analyze data from a wide time range using several time and value filters. To start off, you need to know the following. In the first version, you can only use OBIS values with the aggregation function sum. These are, for example, all consumption values. However, temperature, for example, is not aggregated but used with a maximum or average value. A measured value like this cannot be used for filter analysis. The work area shows 5 charts that have both an input and output function. Years and months as a pie chart, weekdays as a vertical bar chart, the course of the day and the entire time range as a horizontal bar chart. You can also access filter options for the value range as well as a summary on the top right. First, select the time range for the analysis. By default, the current year is loaded. However, you may want to load additional years to gain a better statistic evaluation or compare years. You can now start the analysis and follow your intuition. This is, by the way, a typical procedure for filter analysis. You play with the individual filters and try to deduce a pattern or conclusion. Any entry you make has a direct effect on the different charts. The individual filters add to each other so that all filters are logically applied from a mathematical point of view. Click on the Refresh button to either reset the filters or start a new evaluation view. In our first example, I have loaded the gas consumption data of several years. The annual chart already shows that there have been years with a higher and years with a lower consumption, which might indicate higher or lower temperatures during the heating period. A closer look at the individual months reveals that the colder ones are highly relevant for gas consumption. This assumption is confirmed if we check it against the entire time range. While none of these conclusions are really surprising, but in line with expectations, the differences between the workdays might be more unexpected. You could also take a closer look at the period from 5 to 6 a.m., which stands out from the day's load profile. Findings like these only become visible with the aggregate filtered analysis. In the second example, we want to visualize the effects of a weekend shutdown using a timer program. I have loaded all quarter-hourly period values since 2007, which corresponds to more than 315,000 individual datasets. If you now filter all weekends, you can see a considerable reduction as of spring 2012 and check if this measure was kept or not. You can now filter the shutdown time around 3 a.m. on Saturday morning and look at the daily total before and after the measure was introduced. The summary helps you calculate the totals and thus also the average reduction. In this example, the average daily consumption on a Saturday was 52 kilowatt-hours before and less than 36 kilowatt-hours after the measure was introduced. With a simple timer program, the daily consumption can be cut by nearly a third, which can be seen and quantified with a filter analysis.